Good morning, students. This is Asna Sukla, and today we are going to discuss exercise 1.2 for class 12th. Chapter is relation and function. So let us see first question number 1. So that the function f from r star to r star defined by fx is equal to 1 by x is 1 1 and onto where r star is the set of non-zero real number. If the result is true, if the domain of R is replaced by N with codomain being same R star. So for R star to R star it is 1 1 and on 2. Why? Because R star is a set of non-zero real number. That's why for each x1 x2 belongs to R star, then 1 upon x1 is equal to 1 upon x2. This implies x1 is equal to x2, and it is 1 1. And also if we see for each y belongs to R star, f of 1 upon y must be equal to y, hence it is onto also. So the given function is 1 1 and onto. And if we replace here see domain r star replaced by n. If you replace the domain r star by n, then the function remains 1 1 but not onto. Why? Because domain is replaced by r star n, but n does not contain 1 by 2, 1 by 3, 1 by 4, these type of numbers. That's why it remains 1 1 but not onto. Now we are moving for the question number 2. First part, f from n to n given by fx is equal to x square. So see this function, for each x1 x2 belongs to n, fx1 is equal to fx2, and this implies x1 is equal to x2. So given function is 1 1 but not onto. Why? Because if we consider fy is equal to, if we consider fx is equal to suppose 5, and this belongs to y, so y belongs to y, okay, but fx is equal to what? X square, and x square is equal to 5, so x is equal to plus minus root 5 y, that is n. Fx equal to plus x is equal to plus minus root 5 and does not belongs to n, hence the given function is not onto. That's why the given function, question number 2, the first function is 1 1 but not onto, that is injective but not surjective. Similarly, the given function f from z to z fx is same function from z to z. If we talk about z to z, so you just see minus 1 plus 1 belongs to z. Yes, these are the positive and negative integers. And f minus 1 is equal to minus 1 square, that is 1. F plus 1 is equal to 1 square, that is 1. So you can see minus 1 does not equal to plus 1, but f minus 1 is equal to f plus 1. So this is not injective, that is not 1 1 function. Why? Because minus 1 does not equal to 1, but f minus 1 is equal to f1. This means x1 does not equal to x2, instead of fx1 is equal to fx2. So this is the contradiction of the definition of one function. That's what is not one. Now for onto, if we consider, we talk about the z. So if we consider, see, any element -2, -3 belongs to z. So if we take image of this -2, then this is 2 -2 square, this is 4. So image of this number is always positive number, always a positive number. That's why it is not a onto function. Similarly, next part, r to r. If we see r to r, fx is equal to x square. The same manner, this is neither 1 and nor onto, the same above condition. But if we consider the given function fx is equal to x cube by n to n, so this is 1 but not onto. Why? 1 simply you can see x1 x for each x1 x2 belongs to n, fx1 is equal to fx2, and this implies x1 is equal to x2. But for onto, if we consider any element such that fx is equal to 4, the same condition for question number 4, if fx is equal to 4, then what it is, x cube is equal to 4, so x is equal to 4 to the power 1 by 3, and this particular number does not belongs to what, natural number, and hence this is not a onto. Okay, similarly next you can do. Now question number 3, prove that the greatest integer function f from r to r defined by fx is equal to greatest integer function is neither 1 nor onto. X denotes greatest integer function less than or equal to x. So very simple. If you can consider this particular function fx is equal to bracket x, if you see, you can take x1 as 1.2, x2 as 1.3. You know very well, either 1.2 bracket or bracket 1.3, this both is 1. Okay, so here see, 1.2 does not equal to 1.3, but the bracket of these two values is 1, that is fx1 is equal to fx2, but no, x1 does not equal to x2. So this is not 1 function. This is not 1 function. Now we talked about the, but for onto, if we consider, suppose fx is equal to 2.5, 2.6, whatever we consider, we get fx as a bracket x, this is 2.5. It is not possible. Why? Because bracket x is always an integer. That's why it is not a onto function. So these three questions I already discussed to you. Next you try to solve. Thank you for today.